Hello, this is Mrs. Thompson at Ben Franklin Middle School. We are looking at standard form of a linear equation. So in your textbook, if you were looking, this is lesson 5.5. We're going to be looking at writing those linear equations in standard form and rewriting them in our other forms. So this is our one of our other forms that we've been looking at this point. We're going to identify in our equation ax plus by equals c. We're going to relate the constants. So keeping in mind that the x and y are your variables, and a, b, and c, those are going to be numbers. We call them constants. And they're going to help us find our x-intercept, y-intercept, and our slope. And we can use the definition of what our x and y-intercepts are to help us graph a line. So the standard form, anytime we are talking about the standard form of an equation, this is the form you want to have down. Ax plus by equals c, where a, b, and c are going to be real numbers, and a and b are not both 0. One could be 0, but not both being 0. So just be careful for that. So there are many equivalent forms of standard form of our equation for any line. Like how there could be different point slope equations. So if you use different points and you have the slope, you can come up with a different equation. So there's many equivalents because there are so many general guidelines for standard form. So when we think about standard form, we want to keep these guidelines in mind. Typically, the a term is not negative. So your first term is going to be positive, so not a negative number. Typically, we avoid using fractions and decimals in standard form, unless we're dealing with money or a situation where that might make more sense. Typically, the a, b, and c will not have a common factor, meaning you don't want to have an equation where you have something like 2x plus 4y equals 6, because all of those are divisible by 2. And we could have the equation x plus 2y equals 3, and this would be a better equation because they have no common factors. So thinking about it that way. So our book generally follows these guidelines for answers. So again, keeping your a positive, no fractions or decimals. So a lot of times you might have to multiply by a denominator if you have a fraction, or you might have to multiply by a power of 10 to get rid of a decimal. So as you take a look at the bottom of page 15, we are finding the x and y intercepts. So the x and y intercepts of a graph. Keeping in mind, we've been talking about y-intercept for a while. Remember, y-intercept is when you have 0 with a number. It's on the y line. The x-intercept is going to be just the opposite. It is going to be a number x with 0 for our y-coordinate. So to find the x-intercept, says we are going to substitute in 0 for y and solve for x. So when we go to that equation, instead of y, we put 3x plus 4 times 0 equals 24. 3x equals 24. We divide both sides by 3, and we get our solution, x is 8. Now I want you to look at the numbers in this equation up here. So if we were to identify, we would have said our a in standard form was 3. The b up here would have been 4, and my c value should have been 24. So if we look at this and we're trying to find the x-intercept and we're looking at the values of a, b, and c, which of those three numbers is going to help me get 24? So help me get 8. So I have 3, 4, and 24, and so if I am looking at those three numbers, which value is going to help me come up with finding my x-intercept? And here is the key thing that you need to write down. And again, you might want to pause this video just a little to make sure you're writing this down. But the key thing here is that our x-intercept is the same as taking c and dividing it by a. Remember, we wrote down that our c was 24 and our a was 3. And 24 divided by 3 does give us the x-intercept of 8. So we're going to kind of think about that same thing as we are looking at our y-intercept. So when we find the y-intercept, again, we're substituting in 0 for x. Keeping in mind that the y-intercept is on that y line, and every point on this line has 0 as the x, and then it has a y number. When you find the x-intercept, you are finding on the x-axis, and every point on this x-axis has a point of a number, comma, 0. Number, comma, 0 when we look at that. So replacing the 3 with 0, we get 4y equals 24 and y is 6. And again, if we look at these a, b, and c's, it looks like the c and b if we divide them, and that is exactly how you find your y-intercept in standard form. Now sometimes students have a hard time memorizing this or remembering it. So my hint is, if you're getting stuck, replace. If you're finding y-intercept, you're always replacing the x with the 0. If you're finding the x-intercept, you're replacing the y with the 0 and solving. So that if you don't remember that you are taking the c term, which is 24, and dividing it by, in this case, our b term, which was 4, to get 6. If you don't remember this part down here, make sure you kind of keep in mind what an x and y intercept mean. So in this equation, we are asked to graph the line, and we are asked to find our x and y intercept. This is going to be very helpful as we progress this year, solving equations and looking at it. So first thing for our x-intercept, and again, if we were looking back, we know that to find the x-intercept means two things. It means that the y value is equal to 0, or we can think of it as x equaling c divided by a. Now, if we look at back at our equation, our a is our coefficient of x, which is 1. Our b is our coefficient of y. We'll be very careful here. It is -2. And our c, which is by itself, is also -2. So if I'm finding the x-intercept, I could do two things. I could put y equals 0, and I'd get x equals -2. So if y equals 0, x equals -2. Oh, I wanted to use this. C, -2, divided by a of 1. I still get -2. That means this point on my x-axis is at -2, 0. So my x-intercept is -2, 0. When I go to look for my y-intercept, the y-intercept, keep in mind that means that x equals 0. So in this equation, I could replace x with 0. If I did that, I'd get -2y equals -2. And when I divide both sides, I'd get y equals 1. If I wanted to use my equation from the last page, I'd say c divided by b. And if I look at that, -2 divided by -2, that also gives me 1. So my y-intercept is going to be at 0, 1. My x-intercept was at -2, 0. And now I'm going to take my straight edge and I'm going to draw a nice line that goes through those points. And I really only need 2 points to graph a line. Make sure you're extending that line, putting those arrows on it. And if we wanted to look, once we plotted those points, we draw our line. Could I find the slope of this line? And if we think about the slope, slope is always rise over run. So if I was thinking about this equation and I was looking at my slope, which we've always said is rise over run, is positive because it goes up. So it's a positive. We are rising 1, running 2, rising 1, running 2. So a slope of 1/2. Now, I want you to think about that in relation to these numbers a, b, and c. And here is what we know. Anytime we are finding slope of a line and we know our standard form and we have the variables a, b, and c, this is what we are always going to know, is that the slope, which in this case we just said was 1/2, is always equal to -a, the opposite of a, divided by b. And if we think about that in our problem up here, our a value was, as we are looking at it, 1. So we would have the opposite of 1 divided by b, which was -2. Negative divided by negative gives us a positive 1/2. But again, if you're stuck, remember from those 2 points, you can use your slope formula and find that, subtracting y's over x's, or you can count and use rise over run. As we are taking a look, we're going to be asked to, as you look at these equations, rewrite the equation in standard form. Remember, typically we write the term a first. It's non-negative, using integers for a, b, and c, which means we have no fractions and no decimals as we look at this problem. So the first thing I notice is that I have a denominator of 7. And if I want to get rid of that denominator, the first thing I'm going to do is I'm going to multiply everything by 7. So if I'm taking every single thing times 7, that means I'm going to have 7y equals, I'm going to have negative 7 times 3/7 x, and that's really 7 over 1. And then I have plus 5 times 7. So I have 7y equals, these 7's cancel, and I now have no denominator. I have a negative 3x plus 7 times 5. That kind of looks like 5.7. So I'm going to put parentheses to show my multiplication and get 35. Now again, standard form, keep in mind, is ax plus by equals c. So now I need to get the 35, the number by itself. How do I do that? I add 3x to both sides of my equation. When I've added that 3x to both sides of my equation, I get my new equation, 3x plus 7y equals 35. I want you to try this next one, and what I want you to think of doing is we're going to use the distributive property with that first part, and then we are going to continue. So we have 1y equals negative 1/3 x. Taking negative 1/3 times 6, well, negative times a positive is going to give us negative, and 3 goes into 6 2 times, so that's negative 2, and then we have this plus 2. Well, this is really nice. I got negative 2 plus 2, that's 0. So my new equation is 1y, or y, equals negative 1/3 x. I'm going to keep the plus 0 right now, because our goal is, remember, to get a number by itself, and this time that number is going to be 0. So some students right away will add 1/3 x to both sides. I agree. You could add 1/3 x to both sides of your equation. As you add that 1/3 x to both sides of your equation, you now have 1/3 x plus y equals 0. But we have a fraction, and we said there will be no fractions or decimals in standard form. So at this point, we could take every single thing times 3. If we are doing that, 3 times 1/3 gives us x, 3 times y gives us 3y, and 0 times 3 is going to give us 0. Again, if you need to pause this and go back and kind of take a look at it to think about what we're asking you, please make sure you do that. As you look at this last one, here's the question that we'd like you to write down. So pause this video and write down, if 3x plus 9y equals 0, would that be the correct answer for number 2? So here was our answer for number 2. Would this one work? And if you think about what I said earlier in the video, it actually is correct, although it has a common factor, 3 and 9. So the a, b, and c have a common factor of 3. And if you divide the 3 terms by 3, you get the answer above. That is typically why we write our answer in standard form with no common factors, because there are so many different answers that we could look at. So kind of keep that in mind as you are going through the problems. The last part that we are going to be taking a look at today is, we got a few more things. This is a little longer lesson, is what is standard form of our graph. So we're going to write those equations for both horizontal and vertical. So if we write it in standard form, the first thing you're going to see, 1x plus 0y equals 3. If I look at that, 1x plus 0y equals 3. When x equals 3, that means x equals 3 everywhere. So my x-intercept is going to be 3, because everywhere I put in x is 3. And so as we are looking at that, the question is, will it ever cross the y-line? Well, if we think about every point being 3, right? So here's where x equals 3, and here, and even this fractional one in here, and here, and here, and all of these are where x equals 3. And if we think about where x equals 3 all the time, and we look at that graph, everywhere x is 3, it's a nice vertical line. So when x equals a number, it's vertical. and we think about the y-intercept, it is undefined. It never will cross this y line as you take a look at that. When we look at y equals -2, that means everywhere y is -2. So 0x, we might write, plus 1y equals -2. And again, if I'm thinking about graphing that, y is -2 at this point, for sure, I know that. But all of these points going to the right and to the left, fractions, decimals, are all the place where y equals -2. So the question is, does it have an x-intercept? Will it ever cross that x line? It looks like it's parallel to it. And so we say the x-intercept is undefined because we cannot divide by 0. And the y-intercept, we're going to say, is at -2. And if we look at that graph, everywhere the line goes through is -2. So again, pause this as you're filling in your notes if you need to write this. This is kind of important as we are looking at that y is horizontal. And sometimes I like to tell students, if you flip a y upside down, you get an h. And if you look at the top half of an x, you get a v. So x equals is vertical, y equals horizontal. I'm going to show you another thing that might help you remember this in just a minute. So at the next page, in your notes at the bottom of page 17, we kind of generalize this. And we say if y equals any number, it's a horizontal line. And if x equals any number, it's going to be a vertical line. It says a way of memorizing this is this device called, like a mnemonic, Hoy Vux, if you think about it. Hoy, H-O-Y, horizontal line, slope of 0, starts with y equals. Bucks, vertical line, undefined slope, equation starts with x. Here's the other thing that I really like to do with this is I like to draw a face. We already know that a positive slope goes up. We know a negative slope goes down. We just said a horizontal line has a slope of 0. So here is the person's mouth. That's for my horizontal line. So the y equals, that's our mouth. And the x equals is going to be the nose. And if we said anytime we look at the slope of a vertical line, we have undefined, so we have the u underneath that nose. So that's another thing that helps students remember as they are looking at these. So now the practice down here says write an equation for a vertical line, write an equation for a horizontal line, and write an equation that is neither. And I'd like you to pause the video and try that right now. Key thing, x can equal any number. X equals 1, x equals -3.14, x equals -7/5. All of those are vertical. X equals any number. Horizontal, you should have given me y equals. It could be 1. Could be y equals 0, right? Could be, if we are looking at it, y is equal to -18.95. All of those will be horizontal lines. And then the equation that is neither vertical or horizontal, well, think we have slope-intercept, standard form, and we have point-slope form. So the key thing is y equals, I need to have an x and a y. I could have just y equals 2x. Simple. Y equals x minus 3. X plus y equals 20. You can make it as hard as you want. You could use point slope, but the key thing, if it's neither vertical nor horizontal, you have to have an x and a y. And you can have a number or you can have 0. It doesn't matter. The last problem that you are looking at in our notes for this unit, and then there's just some general summary that we're going to look at. It says an online media store, you can download songs for $1 and movie for $15. You have a total of $60 to spend. Write and graph the equation that describes the number of songs and the purchases. Now, the first thing I want you to take a look at as you look at this problem is we said the number of songs are down here. That means that's my x. So if you want to use the variable x, or if you want to use s, that's going to be when we are talking about our songs. So identifying your variable. So the number of songs is my x. The y, I can already see, is my movies. That's on the y-axis. That's the number of movies I can get. So first thing I want to do is write an equation. And I know it's $1 a song and $15 for a movie. To me, the easiest equation to write, and I'm going to use the x and y, but I'll show you the other way too, is 1x plus 15y equals 60. Now, keep in mind, we want to find our x and y intercept. So if we are looking at this equation, could someone else have written it with the variables 1s? My s sometimes looks like a 5, so I don't use that. 15m equals 60, same equation, right? So just being careful how you write those. Key thing, if we are finding our x intercept and our y intercept. For me, the y-intercept is probably a little easier if I'm looking at it, which it doesn't really matter. But if I want to find my y-intercept, that means when x is 0. When x is 0, I get 15y equals 60 if x equals 0, right? Y-intercept, which means 60 divided by 15. I'm going to put a point at 0.4. So y equals 4. My x-intercept, even a little easier than the y-intercept, right? The x-intercept in this case is when y equals 0. So if y equals 0, I get x equals 60, which means I don't have any movies, and I'm going to put a point over here at 60. Why is it just easy to do those two instead of slope-intercept? Because once I have 2 points, I can draw a line. So when you take a look at your graph, once I have those 2 points, I can connect them with a line, and I'm pretty much done with the problem. Key thing is for this one, I know we've talked a little about being continuous and discrete. We drew a solid line, but really you can't have a solid line here because you cannot buy 3.5 movies. So you really would have a point here and here and here, and you would not have this as being a solid line because we can only have these whole number answers. But when you're graphing it a lot of times, so I would recommend like that you erase part of this and just have the dashed line because you can't get a half of a movie, a half of a song. You have to buy the full thing. So here is our key summary for this, for linear equations. You can describe a line using one or more of the 3 forms of linear equations. Any 2 equations for the same line are considered to be equivalent. So when you look at the graph, we can tell that this one has a slope of 2/3, so it goes down 2 and over 3. The y-intercept is at 0.6. There's a point 3/4. There's an x-intercept. So a line that has several equations to represent it. All of them are correct. They each have their own benefits. So sometimes if you're given a point in the slope, hopefully like the quiz, that was your easiest form, point slope. Y equals -2/3 x minus 3 plus our y point 4. Again, point slope using the point 0.6. Y equals -2/3 x minus 0 plus 6. Now if we distribute this out, we would have had y equals -2/3 x plus 6, or we would have noticed our y-intercept and slope, so slope and y-intercept. And now standard form means that if we were looking at slope-intercept, we would probably have multiplied everything by 3 and added our y to get 2x plus 3y equals 18. So as you are looking at standard form, if you're going to think of shortcuts, these are the ones that you kind of want to think of. As you take a look at those, we are looking at the x-intercept being c divided by a, the y-intercept being c divided by b, and again, if we are thinking about our slope, it is the opposite of a divided by b. As you do your homework tonight, you are working on page 326, 9 to 43 the odd in your textbook. Again, you'll have this so that if you needed to look at it or pause this video because you didn't have your homework, you could see this as you are taking a look, and hopefully if you need to pause it because you don't have your textbook, you can have this open, and that will help you to get that completed for us for class. Thanks and have a good day.